Proxima B, one of the most fascinating exoplanet discoveries to date, was found 6 years ago. It's a solid planet with a size comparable to Earth, orbiting Proxima Centauri, the Sun's nearest neighbor. Scientists have been wondering recently, what would happen if we found other human species in Proxima B? Even though Proxima Centauri, a dim red dwarf star, is close by, it has a notoriously bad temper. It is widely known for hurling enormous quantities of harmful ultraviolet radiation and charged particles into space that render Proxima B inhabitable for humans. But what if extraterrestrial life forms developed a shimmering biological barrier that was both detectable from Earth and capable of converting the effects of Proxima's spasms into something less deadly? Is there actually any other species on this planet? Could humans possibly exist on it? Let's find out. On December 18, 2020, information about a mysterious signal emanating from Proxima Centauri, the star that is closest to our own and is only 4.2 light-years away, was leaked to the British newspaper The Guardian. The signal appeared to come from the direction of our neighboring star and couldn't yet be explained by interference from Earth. It raised the very remote possibility that it is a transmission from an advanced extraterrestrial intelligence, a so-called techno-signal. When Proxima B was discovered by humans, they immediately started theorizing about what kind of life it might have and how to visit. The declaration was made several decades after proof that Xenos aliens from a planet in the Proxima Centauri system had previously traveled between our worlds was published. This evidence indicated that the aliens are roughly 8 to 8.5 feet tall, humanoid in form, and 5 times as powerful as humans. They consume tasteless pills and don't require sleep. They have explored several prehistoric societies on Earth and were most recently seen in Taiwan in December 2012. Many believe this to be nothing but fiction. However, for a very long time, scientists focused mostly on how life might develop on planets around stars similar to our Sun, which is comparatively quiet and warm in comparison to Proxima. Red dwarfs that are cooler and darker have just recently come to the attention of astrobiologists. Astronomers have now discovered a significant and expanding number of exoplanets the size of Earth circling far-off stars in recent years. Some of them are located in the regions where their stars are potentially habitable, where the temperatures would allow liquid water to exist on their surfaces. That is thrilling in and of itself, but Proxima Centauri B is of particular importance since it orbits the star that is closest to our Sun. So what exactly makes Proxima B possibly habitable to humans other than its mass? Unexpectedly, Proxima Centauri B receives from its star roughly the same amount of solar radiation that Earth does from our Sun. Therefore, Proxima Centauri B may have liquid water on its surface in theory. It might be habitable, but of course, flare emissions from red dwarfs like Proxima Centauri makes the question of whether red dwarf exoplanets are habitable much more complicated and intriguing. Although nothing particularly solid is currently known about Proxima Centauri B, the mere fact that it orbits the nearest star to our own solar system provides evidence that Earth and super-Earth-sized exoplanets are prevalent in our galaxy. This is quite encouraging for the quest for life elsewhere. It makes sense to consider what forms of life would have the stamina to endure such stellar wrath, given that data from recent exoplanet surveys suggest worlds surrounding red dwarfs are highly abundant. O'Malley James and Lisa Kaltenegger from Cornell University enter the narrative at this point. The objective, according to Kaltenegger, was to think outside the box and develop a variety of tactics that would enable life on these worlds to survive, and which might also be observable by astronomers looking for extraterrestrial life. On this, Kaltenegger said, "We started to investigate more complex organisms to see whether they had any mechanisms that could provide evidence of life that had not yet occurred to us. Basically, scientists might be able to detect life on other worlds that aren't prevalent on Earth by examining the light we gather. The two of them, Kaltenegger and O'Malley James, started by pondering on all the various shades of life that would be visible in the light reflected from a planet. Then, they dove deep into the mysterious undersea environment, where many animals already resemble aliens in certain ways, and it was then that they discovered corals. On Earth, some corals absorb UV radiation and convert it into light with lower energy. Specialized fluorescing proteins assist them in accomplishing this by absorbing incoming UV or blue light and re-emitting it at a longer wavelength. As a result, when coral is exposed to the proper lighting, these pigments will glow in a distinctive shade of red, green, or orange. Some corals may do this to protect both themselves and the algae they live beside from radiation. They are not the only living things on Earth that fluoresce. Sea turtles, sharks, flowers, fish, and other creatures also shine. However, they could do it more for communication than for defense. Whatever the cause is, fluorescence appears to have independently developed numerous times on this planet. Why ought it to be any different on a distant planet? If Kaltenegger and O'Malley James are correct, Proxima's flares may spark the emergence of a form of life that glows under stress and leaves a visible, fluorescent fingerprint, a subtly glowing indication that we are not alone in this vast universe. This is quite interesting as it ties into recent research by Loeb and his colleagues. Loeb, a Harvard astronomer who specializes in planetary atmosphere research, collaborated with Creedberg on a preprint article for ARXIV. According to his theory, a civilization that orbits its small red dwarf star closely and is therefore likely to be tidally locked with a permanent night side may use powerful mirrors or require extraordinarily bright LED-style lights to illuminate their cities. They claim that if artificial light is present, it will be visible with the James Webb Telescope's near-infrared instrument by looking for telltale signs of LED light waves in the light coming from the planet and its host star. According to Loeb, they may use the light they have found to determine whether or not this world resembles a bare rock. If it doesn't, the oceans and atmosphere, both essential for life, might exist. He claims that concentrating on infrared light, the same color of warm, undetectable light that human bodies continuously emit, can assist in the theory of an atmosphere. Considering that NASA's James Webb Space Telescope was built expressly to investigate infrared light, if extraterrestrial life on Proxima B does in fact exist, it's certainly up to detecting it. The stability of an atmosphere is a key concern for Proxima Centauri B's habitability, because of the strong UV and X-ray radiation that comes from Proxima Centauri. Proxima Centauri B experiences this radiation, particularly X-rays, 10 to 60 times more than Earth does. From what we've gathered, the likelihood of the human species being on Proxima B is very low, unless some sort of rapid evolution takes place. Because it is so far away, scientists are yet to determine if it has an atmosphere. Even if a planet had an atmosphere, it could not be the proper one to support human life if its surface was frozen and had a temperature of -40 degrees Celsius. Alternatively, it might be tidally locked to Proxima Centauri, in which case one side of the planet would always face the star while the other was enveloped in darkness. Let's say we were to send some astronauts to Proxima B. Traveling in space may present some unpleasant surprises. The crew members would lose bone density and muscle mass if they spent their entire lives in zero gravity. Radiation from space would ail them continually. Their physiology, immune systems, and microbiomes would alter their culture and values. They might forget everything we taught them about farming so they could survive in space and on their new planet. Because a species would need to arise and grow in quite different circumstances, we believe if life exists on Proxima B, it would need to be a different sort of life than what exists on our own planet. If there are moons of Proxima B, scientists say they may have the best odds for supporting life in the Proxima system because they are not tidally bound to the star. In the hypothetical case that we could reach there, experts say our best bet is to drill and explore life beneath the surface, seeing as it's most likely to be frozen solid. Because the surface circumstances surrounding a red dwarf are extremely difficult for the planet to support life, it probably would be best to look below. Do you think there's human life on Proxima B? Comment below.